went. So guys, come closer. You can sit on the chairs. So today we are discussing the future of peer-to-peer technology and also about Web3 infrastructure. We have amazing speakers. So Vuk will start our discussion. After this, we will have a small break. And after the break, we will have panel discussion. Also, you can ask questions, be active, and let's let's support our first speaker.
Yeah, probably I should just be here since I don't have a clicker. Can you hear me all right? Yeah. Okay. Yeah. Yeah. Yeah, of course.
You need some? You need some? No? No, please. All right. 1 second.
Hey everyone, my name is Vuk. Should we start? Yeah. My name is Vuk. I'm the founder of a spin-off from Protocol Labs called Filmine. So basically what we're doing is we're building some protocols that allow different actors to be coordinated and provide infrastructure to the Web3. Before joining Protocol Labs, I did a bunch of things. I built EVM dev tool startup back in 2010, spent 2 times in the Ethereum ecosystem, then spent 1 year in the Cardano ecosystem, building on top of Haskell and a bunch of like protocol-specific things for sidechains and so on, and then joined the Protocol Labs core team of Filecoin and IPFS. So generally what I want to talk about is how to think about where we are going with the decentralization of the cloud. If you think about what the cloud is today, it's basically just a resource pool where you have storage and compute. And if you look at all the details on how like the cloud evolved in the past 20 years, you basically have storage, which is backed by big network-attached storage. Usually you access that storage through services like S3, and you're reading from S3 from VMs. And VMs are basically the way that cloud providers give you the ability to isolate resource and basically buy particular resources. You can buy cores, you can buy memory, you can buy IOPS on some local SSDs, and then you can interact with the massive storage through services like S3. Every other cloud product that you use today, like Kubernetes or any load balancer or any machine learning framework that is running on top of cloud providers, is basically running on top of those abstractions. So there is nothing more than EC2 and S3 if you think about the fundamental layer. It's really incredible to see that clouds are growing at 30% year over year after 17 years after they were kind of invented. Even though we have so many issues with the clouds, like the fact that they force you to be locked into a particular infrastructure provider. What I mean by that is that you don't have an option to be running on a particular server that you wish. When you use AWS or any other cloud provider, you're basically forced to use a cloud provider, infrastructure that is backed by that cloud provider. And usually that cloud provider is based in a particular jurisdiction, so they have like very strict rules on what they need to do with that data. For example, if someone needs to read that data, like they are happy to share that data with whoever the authorities are in their respective jurisdictions. The issue as well is that everyone is building their own tools. So if you think about AWS, Google, Azure, like they all have the same products with a different brand. and they're basically just building everything from scratch without really sharing anything between them. Now, the worst thing is that all that infrastructure is then being used by other tools built on top of those tools. And then what happens is that we have services like Firebase that really don't even give you an option to choose. Like you use Firebase, everything gets abstracted away for you, and at the end you're using Google Cloud, and you're basically inheriting a bunch of things related to like how your data is treated, which is completely wrong. Now, especially in a time in history where there is a lot of geopolitical instability, giving rights to a particular country that is not the country that you live in with your data is a super bad thing to do. And ultimately what's happening is that most of those companies, at the end of the day, because they are for-profit companies and they need to do whatever is for profit, they're really not making decisions on what's better for the data of their users, rather what's better for the shareholders. And they're really not doing that because they are evil. They're rather doing that because those are the obligations that they signed in when they wanted to run those companies. Now, if you compare what's happening in Web 2 and what's happening in Web3, and we look at how fast the Web3 ecosystem is growing, we are seeing Filecoin grow in 18 months to 17 exabytes of capacity. And if we compare that to what happened in the case of Web 2, we can see that over the period of 6 years, you have AWS, Google Cloud, and Azure collectively have 15 exabytes of capacity. So it took 6 years to AWS, together with the Google Cloud and Azure, to get to 15 exabytes. And Filecoin launched in 2020, and we are now seeing 17 exabytes of capacity. So that's not even 2 years, and that's just one network. And then if you look at all the nice characteristics that WebFree Clouds would give you, like being able to choose the infrastructure provider that you want to use, because now you're referencing the data by the content rather than the location of the data. Being able to use the same tools across many infrastructure providers, and allowing people to contribute to that infrastructure by just plugging in their infrastructure, for example, your computer at home. And ultimately, what we're also all together getting to is an internet that cannot be broken. Because if you look at what's happening today in various jurisdictions, we are very likely to have a few intranets that are completely separate between each other. And the reason for that is that countries are kind of trying to, there are a bunch of conflicts that are kind of putting countries in particular positions that they are just trying to like hoard data of the users and not allow other jurisdictions to get into their countries. Now, if you think about Web3 and how and what it really means to be providing infrastructure to those networks, is at the end what we are going to have instead of products like S3 and Compute is networks of infrastructure providers, which we also frequently call miners, that are basically providing their infrastructure and resources in order to do a particular computing workload. And those are networks. And what we are seeing right now is a bunch of networks that are focused on building and solving a particular use case. For in the case of Fluence, that's FASM executables. In the case of Livepeer, that's encoding video. In the case of Aleo, that's doing ZK snarks. And everyone is focused on one particular use case. So what's actually happening is that in the Web3 context, we are first solving the different products, and we yet have to solve the infrastructure that is allowing to those different networks to have a resource pool on top of which to execute their workloads. And what we are trying to do is provide a common infrastructure on top of which those compute networks could run their workloads. This means that instead of having a bunch of miners that are spread all across the globe that are pretty disconnected like this, we are trying to get in a position where those miners are basically able to run all their workloads that are doing a particular kind of thing, for example, computing, and have them relatively well connected with the data providers, in this case IPFS and Filecoin, which can also be looked as archival networks, retrieval networks, and the compute networks that are basically providing the compute. If we focus on the archival network, what we have is basically we have miners providing storage, in this case to the Filecoin network, by having big racks full of hard drives, full of data, and also having that particular storage backed by field collateral. And in this case, it's super important for us that that infrastructure is secure, because what's backing that data is really collateral that is worth a lot. So in the case of Filecoin, that can be for 1 petabyte, you might be required to have like 50,000 USD in collateral backing 1 petabyte of data, 1 terabyte of data. Now, if you need to do retrieval, what you want is more a small machine that you can put in basically a hotel room where you have a lot of bandwidth. You have a machine that is connected to a residential connection, because of which it's a very affordable connection, but you're very limited in terms of storage. But you don't really care about massive storage. What you care about is providing a particular piece of content to the final user. And if we look at computing, what you actually care about is executing massively scalable jobs at a very low cost. But at the same time, those compute providers usually are not as reliable, so you really want to pay attention on what kind of workloads you're running on those compute providers, and especially because they have a very limited connection. So you are not able to transfer as much data as you would be able to transfer to a retrieval provider or their Halo provider. Now, this is just the beginning of computing. What we're going to see is very specialized compute providers. For example, some compute providers might have high IOPS on the SSDs and might have like very specialized hardware doing a particular workload. What we are trying to do is basically build protocols that coordinate all those actors that are providing the infrastructure with the different networks that are basically allowing us to define those workloads that are going to be run on those infrastructure providers. And you could think of that as being the EC2 and S3 of the Web3 context. Now, if we zoom out and we look at the different personas that are actually participating in this ecosystem, you have the storage providers that care only about getting predictable rewards, not being exposed to the price of the cryptocurrency, because what they care about is just running a business. And those can be seen as hosting companies back in the 2000s that were just doing hosting. They just care about hard drives. They care, of course, a bit about the networking. Maybe they want to be on internet exchanges, but they don't really care about betting on a particular scenario in the case of crypto. And what they also care about is being able to scale. So if they have some demand, they want to be able to keep adding racks full of drives and be able to scale their business. On the other side, you have the compute providers, which are basically a new persona. If you look at like what's happening in the past 50 years, that persona is the persona of a proof of work miner that is just focused on getting very cheap electricity, very cheap hardware. They're very resourceful in terms of how they connect their hardware, how they cool their hardware, and what are the things that are running on top of their hardware. And what they care about is just getting the highest reward possible for that CapEx that they have, and being able to be also very flexible. So they don't want to be forced to be running something all the time. What they want is just be able to get some rewards when they want to invest those resources in a computing network. And ultimately, a role that is super important in the Web3 context is the token holder, because Web3 networks have to think about how to generate demand for their token, because those economies need to be sustainable, because at the end of the day, most of the computing and storage networks are rewarding the infrastructure providers through inflation. And if there is no demand for that particular token, it's super hard for that economy to sustain. Now, I'm going to make a few examples on what we are specifically working on, since probably right now everything is a bit too high level. One of the products that we launched 6 months ago is the Liquidity Protocol in the case of the Falcon network. So Falcon does not have native staking. And the reason for that is that in order to protect the data that is being stored on Falcon, there is the concept of collateral locked to that particular data. And that is basically allowing Falcon to connect the liquidity with the particular utility that the Falcon network is providing. This is great for you if you want to store the data, but it's also super problematic for the economy because you need to very precisely coordinate the liquidity and the utility that is being provided to the network. This means that the storage provider will need that liquidity in order to provide the service, in this case the utility, and they need to be able to access the liquidity somehow. So what we have built is basically a way for storage providers to take liquidity from token holders, provide the service to the Falcon network, get rewarded in Falcon, and split those rewards with the token holders. At some point, we have also introduced the role of the compute provider, which is basically further helping the storage provider just do storage. And in this particular case, you can see that the storage provider is paying for the compute provider to do the preparation of the data. And this is a new role in the Falcon network that allows basically the preparation of the data to be offloaded to a separate persona rather than the storage provider doing it. This is super important because what you want is to be able to scale horizontally. And if you're doing both computing and storage, it's super hard for you to orchestrate those workloads inside of a data center. And if you zoom into the compute provider, basically the compute provider is just getting some data from IPFS or Falcon. It's preparing that data, and it's doing the compute workload that is necessary to onboard the data to the Falcon network, which is called sealing, which is basically doing proof of replication that is required to be able to efficiently prove to the network that the data is really stored there. You could as well think of like multiple workloads running on those compute providers like Livepeer, Fluence, and so on. And to wrap up, basically, what is the WebFree Cloud? The WebFree Cloud, in our opinion, is just a way of looking at different ecosystems and coordinating the different actors in those ecosystems, like developers building on top of Fluence that have like a demand for compute, the compute providers having some resources, storage providers having the data on top of which that compute needs to be done, and just allowing them to just focus on one particular thing and just coordinating their resources through the network. Yeah, that's kind of it. Thanks for your time. Both our team and the Protocol Labs are hiring, so Google Protocol Labs jobs, or just drop me a message. And yeah, thanks.
Thank you, Vuk, for inspiring talk. Now we're ready for some questions. Anyone? Questions? Come on, guys, yeah.
Is there already a formal relationship with Livepeer?
Kinda. Yeah, I mean, like we talked to Doug several times, so.
Okay, so that was a hypothetical example of a storage or compute
Yeah,
provider.
so
Okay.
let's get back here. So in the case of Livepeer, you have two personas. So you have the validator that is orchestrator in the case of Livepeer. That's kind of how it's called. So Livepeer does not have the link between the utility provided and the work necessary for that utility to. So basically, you can stake into our orchestrator, but that orchestrator is not required to do that utility. So you could imagine having those validators ask workers, which are compute nodes, to do just the small pieces of encoding, and basically with that help the orchestrators get more rewards because they would be able to be more efficient, and with that they could allow a higher yield to the people staking into those orchestrators. In the case of Livepeer, right now it's super small in terms of like demand for computing. It's more about building the reputation on the orchestrator level, getting enough liquidity into those orchestrators, and then focusing on the compute. So in this particular case, it is theoretical, but when the demand is there, like it's definitely gonna become more than theoretical.
Okay, thank you. And I encourage you to look at our project Functional Land, built on IPFS, but does compute and storage, and maybe there's some work we could talk about.
Okay, thanks.
Any questions? Yeah, you can ask later. Ah, I see a hand. Sorry, it's a little bit dark.
It's pretty cool. What do you think, after kind of stealing and so on, what do you think is the next thing that you would like to see somebody build?
Yeah, we are super excited about the work that Fluence is doing, and I think Fluence is going to be like the infrastructure for like many other use cases. The reason why sealing is super interesting is the fact that it's a workload that has like unlimited demand because of the way that Falcon was designed, and this is probably one of the very rare workloads that have like unlimited demand. So any workload that has a lot of demand and can be easily parallelized is something super impactful. And if you think about the fact that by using decentralized computing, you can get 20 to 30x more efficient computing, it's a big opportunity for anyone to harness.
What are your guesses at like what the next thing will be?
I would love to see machine learning,
Thanks.
but that's super hard.
Thank you. If somebody have questions, you can ask later. Vuk, we will be still here for 1 more hour when we finish our official part. And now our second speaker, Justina Petraite, developer success lead in Ceramic Network. Please welcome Justina.
Dull people problems. All right, hi everyone. It's so great to be here. I hope everyone had a great week. Last week there were so many great events in Lisbon, and this week is super exciting as well. Before I start, I have to apologize in advance. I made a decision to go a dentist today. I thought it's a good idea to do that on the same day as I do a talk. So if I make a little pause or a weird facial expression, it's because of that. I'm not weird in general, I promise. Yeah, so super happy to be here and talk about why composable data is something we should think about as we build out Web3, and why me and I believe my team, Ceramic, believes that it's one of the core pieces that are really important to build a better and more powerful web. So I'm Justina, and I work as a developer success lead at Ceramic. Before joining Ceramic, I worked in Web2 for most of my career. I was a data scientist and also focused on machine learning and conversational AI for quite a few years before joining Ceramic team, and now I bring some of that experience to Web3 and also learning so much. I think Web3 data overall is such an interesting and fast-growing field right now, and I believe that we have such an amazing chance to do something really exciting and hopefully better than things that we have in Web 2. So super excited to be part of that. If you want to talk to me after this presentation and in general share ideas and have discussions, obviously you see my Twitter and my email, so feel free to reach out. I'm super happy to talk to anyone who are interested in these topics. I mentioned that I'm from Ceramic. For those who have never heard this name, Ceramic is a decentralized network that brings composable data to Web3 applications. The team of Ceramic has been around for quite some time now, since 2016, and they have been focused on building out the infrastructure and the APIs that allow developers to easily store, modify, access, and use data on a decentralized network. And the core piece of Ceramic is composability. We really try to make sure that developers can easily reuse and repurpose the data across the network. We aim to build out a network of applications that run on composable data. Another really big part of what Ceramic team is focused on is decentralized identity, providing the tools that would make it easier to build applications with better identity management options. You can see on the screen a few tools that Ceramic team has built so far. Ceramic Core, Glaze, which is a developer suite built on Ceramic, also Self-ID for identity management, and Cacao for session management and delegation. And also everything that we do, we try to build on or even create new Web3 standards so that we contribute to the space and making sure that it's better defined, more standardized, and in general better to build on. So yeah, let's talk about composable data. In general, I think most of the people in this room are already familiar with composability from software perspective, and open source is really at the core of composability in general, because we have so many applications that were built in Web3, even over the past few years, that have been built on some kind of other open source project that was built before. And it's great because developers can build faster, can build better tools, and it's helps with innovation. And I think that was one of the catalysts of why we had so many great applications built on Web3 over the past few years. Most of the applications, though, I will dare to say, were quite simple in terms of what kind of features they have. And most of them are obviously really great in terms of financial applications, but if we compare them with regular Web2 applications, especially things like, I don't know, Web3 social, gaming, and things like that, they are a little bit behind. And the reason why is because we don't really have good tools and good infra to handle data that is not financial data. And also there are reasons of it's expensive to store data on chain, it's also quite slow. So at Ceramic we try to solve these issues by providing the tools that are built on a blockchain. And it goes beyond that. If we look at how things even are built in Web2, there are some issues on both user and developer side. So for example, from user perspective, I'll give just one example. Let's say I want to use a social app. Again, we are in a Web2 world here. I sign up for that social app. Most of the time, I will have to provide some kind of information about myself, my name, my birthday, my location, and then some kind of preferences for that application, colors, theme, and things like that. And later on, I will invest my time in building out my social graph. So people that I follow, people that follow me, and things like that. If I sign up on another social application, the same process goes once again. I have to do exact same things again and again. It's not only tedious to do that every single time, but also there are some aspects of user experience that go beyond just having to create a new account every single time. Let's say if I am a creator and I have millions of followers on one account, if I want to branch out into some kind of new application, I have to build everything from zero once again. I think that's why I noticed that on YouTube we have so many YouTubers that have one massive channel and then some other smaller ones, and then they always say, please go and follow me on this other channel as well. From developer perspective, this is not great as well because you have to do the same development over and over again for every new application you are building. So this is extremely simplified, but this is how things look like most of the time in Web 2. Developers have to build out the systems where users can interact with some kind of server that has some kind of APIs. They pull some data from somewhere, they store some data in a centralized database somewhere, and then the user gets some kind of view that they see when they interact. Again, the problem is that developers have to build the same thing over and over again for most of the applications out there because, for example, all of the social apps, they need features like user profile, they need features like follow, and things like that. So it's all repeated. And then another thing that I personally experienced while working as a data scientist is that all information on Web2 obviously is really siloed. Each company, each application has its own centralized database where they store the data. From machine learning perspective, it's extremely painful because most of those applications, they want to enhance user experience by building some kind of machine learning systems on top, for example, recommendation engines and so on. And as a data scientist trying to build some kind of good system on really limited amounts of data is hard. So there have to be some kind of better solutions that would make life easier for both the users and the developers. And at Ceramic, we believe that one of the solutions for that is thinking about data in Web3 through the lens of components of, for example, data models. And data model on Ceramic Network is really the core piece that developers can use to build out their data layer in their application. So the core idea here is that as a developer, you can define a data model that would include some kind of description, what that model is for example, it can be for a user profile. And then in the core of that data model, you have a schema, which defines what kind of data will be stored in that model and what kind of maybe relations this data model will have with other data models. And since we build on decentralized network, applications that are built on it, they can share those data models. For example, we have this DApp number 1 that I mentioned before. It will use that, let's say, user profile data model. And then if we have another app that is built on the same network, it can just simply take that data model. Developers don't have to build it from scratch, and the data that is on the decentralized network is going to be synced across both models. What that means for the user is that they can take their data with them. So for example, if I am a user of DApp number 1, I created my profile, I have some followers there, then if I sign up for DApp number 2, all of that information will be available for me there. My profile, people that I follow that are using the same DApp, and so on. For developer, that means that they, first of all, don't have to reinvent the wheel for every single social app they are building, and they have more data to work with in general. So that's advantage for example, data people and people that are trying to drive some kind of insights from data that is available. Very important part about all of this, though, I really like the idea that with a lot of freedom comes very big responsibility. It's great that we can make all of this data available on the network, that it can be synced across different applications, but then at the same time, we have to make sure that user data, which quite often it can be quite sensitive data, that is secure and that users have the ownership of that data. So another really important concept that we talk about quite a lot at Ceramic is how we can make sure that users have the ownership of their data and that their data is really sovereign. Some examples of that sovereign data is profile details, like obviously your name, surname, and things like that. But then it goes beyond that. That includes it can include your social graph, verifiable credentials, NFTs, and really there are a lot of details there. The core idea here and how we build Ceramic is that user data in general should be all managed by DIDs, decentralized identifiers. DIDs are the core of Ceramic as a tool in general. And when users interact with the Ceramic network and the apps that are built on Ceramic network, all of their data that is generated while they interact with those applications are connected to their decentralized identifiers, meaning that only the user and the user only can write to data streams, can make updates to those data streams, and also see the history of the updates, and so on. Obviously, there is still open question, I would say, how do we make sure that all of this open data on the network can be compliant with some regulations like GDPR and things like that. It's still, as I said, open question, and obviously you have options like encryption and so on. We have some projects that are using Ceramic. They are encrypting the data. That also, at least right now, comes at the cost of composability, because you can't really have that shared infrastructure of applications that can access the data of your application, but that's a possible use case to store data in an even more secure way. And I think that's really the key that will power web in the future. And there are quite a few, in general, advantages of aiming to have this open-sourced information available on the network. So first of all, we de-silo the data. It's important. It's scary how much personal, easily identifiable information is stored on centralized databases, and that opens so many doors from just in general data security, but also, I mentioned a few times, machine learning and even decentralized science progress. We also at Ceramic believe that all of this should be built in the open and community-driven. So we want to make sure that there are some standards around what kind of models should be available, what kind of consensus is around developing them, and instead of having then hundreds of tools out there to provide different options of how data can be shared on the network. Maybe let's create some kind of standards and consensus around that all developers could share and use. And also user agency is extremely important. Again, as I said, it's cool that we can share it in the open, but we have to make sure that users have the agency of their data. They can decide what's being done with their data and where it goes. I think I covered most of the slide in general as I spoke about that. It will definitely power the Web3 as we go forward with open source data powered through organizations and identities, better value prop for developers and for the users that is offered through the decentralized network that makes all the composability and data interoperability possible, and also software. We can have much better version control on a decentralized network, because as long as we have node operators running the nodes, it will all be available for developers to use. And just a few notes about Ceramic, specifically how we try to solve all of these challenges around data in Web3. So on Ceramic, you can store dynamic content. There is really no specific limitation on what kind of content can be stored on Ceramic. We have companies in Web3 Social doing that. Gitcoin Passport is built on Ceramic as well. Gaming data can be stored on Ceramic. Verifiable credentials, really anything. As I mentioned, the core building block of Ceramic is data model. So developers are free to build and share data models whatever way they like them to be built. And Ceramic is a decentralized peer-to-peer network, which means that data is always available, and as long as there are nodes running, your data will be there and accessible, and no centralized company can take down an API and make the data unavailable for your application as well. And also, we provide the DID, decentralized identity management tools that make it easier to do that connection between the user and their data. And the key components of that, we have Ceramic Node, which is the key block that makes all the network running. And then we have ComposDB, which we actually built out and are still building right now. And it's a pretty new product, which has GraphQL API, it has indexing and things like that. Right now it's in a developer preview mode, so we really appreciate developers trying it out and sharing the feedback on what can be done better. The very top in this list is data composites. So you can build out different models for your application and then basically compose them and define how your application's architecture looks like. And yeah, I mentioned some examples of companies that are building on Ceramic today. As I said, we have a really big range of applications for Ceramic. Even last week, there were quite a few interesting conversations that we had from different companies, for example, insurance companies interested in using Ceramic for storing data. So it's really exciting to see what kind of applications we have. DAOs as well are really interested in something like Ceramic to store data, and especially for verifiable credentials and reputation. And right now we are working on 4 key things. So we are improving the data models, how they are defined. Again, I mentioned we have GraphQL API, which makes it much easier to define schemas for the models and also interact with the data on the network. We added indexing, which will make data retrieval faster. And now we are focusing as well on scaling the network so that it's fast, reliable, and is production ready. We actually added the sign-in with Ethereum and did PKH options. So basically, that means that anyone that has a wallet now can have a DID and hopefully use Ceramic as well to store their data. So that's all from my end. If you want to learn more, you can also join our Discord. This is where our community is and most of the Ceramic team. And if you have any questions, let me know. Thank you.
Christina, questions, guys? I see.
Thank you. Hey, do you have any requests from underlying layers to improve the data model? So it's really cool that you're using GraphQL and so on. There's a lot of people working on data models and access controls and deities. If you were to like wave a magic wand and have the infrastructure get better and improve for Ceramic, what would you ask for?
That's a great question. I think in general, it's like the feedback that we got from developers so far having to use GraphQL is that it's just much easier to understand what is necessary and how to define data models. So I think another concept that developers have to understand is, for example, how to define relations between different data models. So I think that's really the core piece in making it as easy as possible to do that, because for experienced Web3 developers, we see that it's easy to grasp the ideas behind that because it's slightly different from traditional databases and how they work and how they are defined. But for especially people that are coming from Web 2 to Web 3, it's a little bit harder to understand. So I would say especially the relations between the models, something that we have to make it easy to understand and define as well, something that we are working on as well right now.
Thank you. Any questions? I cannot see anything. Okay.
Hi. Personal question. What kind of apps would you like to see being built on Ceramic?
Oh, that's a great question. I would definitely love to see some gaming, Web3 gaming apps. That's my personal response because I worked in gaming for a bit. I love that field in general. And when I joined Web3, I was so excited to see that there are so many interesting projects popping up. But after trying quite a few of them, I would say they are still lacking in terms of what kind of features there are and just in general how gameplay feels like. So with Ceramic, you can definitely do that more. Something that I haven't mentioned is that we sign in with Ethereum and tools like Kakao that Ceramic also built out. You can have session management and delegation in your apps, which means that users don't have to approve every single action that they do with the app because they are delegating the entity, the app, to run the action on their behalf. And that, in my opinion, opens up so many possibilities for interesting applications. So gaming, I think, is a great example of that. And then I think reputation in Web3 is still quite open field. I think we really have to figure out how to build out those kind of tools, especially for DAOs. So I think that's something that I also would like to see happening on Ceramic.
Follow up. Do you think reputation can be different in Web3 than it was in Web2?
Yeah, I hope so. I think there are some components that obviously we need in Web3 that are present in Web2 as well. For example, how do you make sure that the issuer of some kind of credential is official and things like that. We had interesting discussion last week with some of my colleagues about just in general, the perception of reputation in Web2, that it's, in some cases, for example, your credit score is your, it is your reputation, but not managed in a way that easily it can be made your anti-reputation, if, or even your medical records and how your insurance companies are calculating scores on what kind of premiums you will have to pay based on your medical history. So I think, I hope that with Web3 we can have better solutions to who can access that data, how the data can be used, yeah, what it's done with that data and how that impacts life of people. So I don't have the answer how, but it's just something that I would like to see happening better.
Very much. Oh, sorry. Thank you very much, Justina. Some
Thank you.
applause. Thank you. We have one more speaker from Livepeer. Please, Yondon, come to us on the stage. Yondon is co-founder and the engineer of Livepeer.
I can just use this one, right? Okay. What do I have to do? Oh, okay. There we go. Cool. All right, I'm going to get started. Thanks everyone for having me tonight. My name is Yondon, and I'm one of the co-founders of Livepeer. Livepeer is a decentralized video streaming network, and I'm going to get into a little bit more about what that means later on in the talk, but let's get started by going over the agenda. So I'm going to talk about 3 different concepts today. The first one is this notion of video compute on decentralized storage. Then I'm going to talk a little bit about a feature that we built recently that falls into this category, which we call IPFS CID video streaming playback. And we think that this is a feature that helps illustrate some of the concepts that we've been working on in this realm of video compute on decentralized storage. And then lastly, I'm going to talk about, by taking a step back, this decentralized storage video compute pipeline. So the CID video streaming playback feature, we think, illustrates a flavor of this pipeline, but this is a more forward-looking conversation about what this pipeline could look like in the future. So let's talk about video compute on decentralized storage. So to help illustrate this a little bit better, I think a good starting point is NFTs. So what's interesting about NFTs are that they are on-chain assets that have on-chain property rights, but some of the most interesting things about the NFTs are actually off-chain or in the metadata associated with an NFT. And that metadata might contain things such as traits, attributes, but more importantly, links to off-chain content, whether that be images, videos, text, etc. And what's been really cool to see in the NFT space is that we've slowly started to standardize the way that we reference a lot of different files and assets and content in this NFT metadata. And at Livepeer, the type of content, obviously, that we care about most is videos. So what's nice is that whether it be through IPFS CIDs or various other cryptographic IDs in the space, we're able to create this shared verifiable data layer by verifiably linking a piece of data that's off-chain with an NFT that's on-chain. And this establishes this shared verifiable data layer because with something like a CID, with something like a cryptographic ID, you can verify that this actually points to the correct data and it's a verifiable link, as opposed to, say, providing an HTTP URL, which could break if that location stops serving that particular content. So we think this notion of CIDs and generally cryptographic IDs as a shared verifiable data layer is pretty interesting as a base. And for the rest of this presentation, I'm going to refer to CIDs a lot, but generally we think this can apply to any form of cryptographic identifier that can be verifiably linked with the content itself. So at Livepeer, we think of CIDs as base ingredients for enhanced renditions. Now, what does this mean in practice? What's interesting about video on the internet is that very rarely do you actually watch the original video that was created by someone. And this doesn't mean that the visual content is different. This just means that bit for bit, you're very rarely watching the same exact video, whether that be a live stream or a video that was uploaded to YouTube. And that's because there's a whole lot of stuff that happens under the hood in terms of compute and processing after video has been streamed or after video has been uploaded in order to make it work really well. And this is something that I'll dive into a little bit further on, but this is a process that's called transcoding, and that's usually the starting point for a lot of this compute, where you want to basically take a single video that comes in and translate it into different versions so that regardless of where you are around the world, what device you're on, things just work. So that's a little bit problematic though, right? Because if we have a standardized reference via a single CID to a piece of video content, what do you do about all these other renditions that you care about, right? You're only pointing at a single given file. But I think one way that we can think about it is we can work with that. We can use the CID as a base and as a root for the rest of a compute pipeline, where you can start with a CID that represents some original video file that you care about, and that's the original visual content. But you can apply compute on it on a layer on top in order to create something more interesting and create an enhanced version of that video. So the example that I'll go through here that hopefully can help illustrate why you might want to do this is, let's say that you have an NFT and it's linked with some metadata object. And within the metadata object, you have a CID link to, I'm sure many people have been rickrolled here, to the Rick Astley MP4 file, right? And what's interesting about the reason that I chose the Rickroll video and the Rick Astley music video is because actually last year, someone thought it would be a really good idea to create a better version of the Rickroll video, because the Rick Astley music video came out quite a while ago, and around that time, the encoding technologies and the video technologies weren't able to capture a truly high-res version of that music video. So if you've ever been Rickrolled, it's a pretty grainy experience. And someone decided that wouldn't it be great if you could Rickroll people in 4K? How would you do that? Well, thanks to some more advanced video AI techniques these days, you can actually apply a technique called super resolution and upscale and increase the resolution from an original grainy video and restore it back. So that's pretty cool. You end up with this enhanced version of the original video. And how do you deal with that in this context where we have a single CID that was linked with the NFT metadata? Well, we can visualize and see this compute layer that's applied on top of the CIDs, where the CID is the root, and it can be passed into this pipeline. And one of the compute that you can apply is this super resolution technique. So in on one side comes the CID for the Rickroll video, and out on the other side comes the 4K version of that. And it's all still rooted back in the original CID. So this brings me to something that we've been working on recently that hopefully can help illustrate this a little bit more concretely and less theoretically, which is this feature that we call IPFS CID video streaming playback. And this brings me back to this topic of transcoding that I was talking about earlier, where the plumbing of video streaming online today really oftentimes starts at this process called transcoding. And why do you want transcoding? Well, two of the main reasons here are that, one, you want to shorten the time it takes to play back a video. You don't want to sit there, press play, and wait 2, 3, 5 seconds before anything plays. But if all you're working with are singular MP4 files, that's going to be a part of the experience that you get, because the way that MP4 files work is that you actually have to download a whole bunch of data up front before you can actually start playing back any of the rest of the file, even if you're trying to stream chunks of that file back to you in the player. The other big thing that you want to support with transcoding is something called adaptive bitrate streaming. And adaptive bitrate streaming is best illustrated by this UI that you see here for YouTube. And normally as a user, you don't have to actually manually choose any of these things, but I think this helps illustrates what adaptive bitrate streaming is, where you can see that there's these different quality profiles that you can choose from. So 720p, 480p, 360p. And right now, the UI just selects auto, which means that the player is intelligent enough to basically monitor the bandwidth fluctuations on your machine and help you decide which profile that you should be playing back at any point in time. And this is why, if you try watching a video on YouTube on your mobile connection here, on the really crappy Wi-Fi at a conference, or at home on your fiber optic connection, you're still watching the same visual content, and it's unbroken and it's uninterrupted. You're just constantly dynamically switching between different versions of the same content. And that's why the experience is so good on YouTube. And that's actually the experience that we would need to get to in a Web3 context in order to replicate the same types of consumer experiences that people are already accustomed to. So those are just some of the reasons that you would care about transcoding, and hopefully after that, I've convinced you that it matters and it is a really big part of ensuring a high quality experience for internet video. So that brings me to a little bit about what Livepeer does. So Livepeer is a protocol and a network that helps establish this global, open, decentralized video infrastructure network. And transcoding is one of the most important tasks that nodes on the network complete. So they're responsible for taking video in, doing the necessary compute and processing so that all the things that I mentioned, such as short time to playback, adaptive bitrate streaming, just work, and it's powered by this decentralized network of nodes. We've built this Livepeer Studio product, which you can think of as a gateway to the Livepeer network. So it's a hosted API that makes it easy in order to tap into the functionality that this network of nodes offers. And today we power a whole slew of different video applications in both the Web3 and Web2 space, including some of the ones mentioned here. So this brings me to the actual feature. So what we want to be able to enable is transcoded videos for CIDs. So you can have a CID reference to an existing video file in IPFS and as is, the only thing that you could do is play it directly from a gateway, or maybe that you can fetch it from one of the retrieval markets. But at the end of the day, all you can do is play back that exact file. But what we would like people to be able to do is say, I have a CID and I just want transcoded playback to work. I want adaptive bitrate streaming. I want short time to playback, and I want to continue referencing this using my CID. So that's actually along the lines of what we built. So basically how this works is that, let's say that you have an NFT once again and a metadata object associated with it, and it has a CID reference to some video. We can actually pull that video into Livepeer, apply the transcode in the video compute pipeline, and out on the other side comes the transcoded renditions. So in comes the CID for an MP4 file, out comes the transcoded renditions that can be relayed back to a video player on the client side, and you get this high quality playback experience. So we have a demo page called Play a Video from IPFS that actually illustrates this, and hopefully if this works, I'm going to show a quick demo video of the actual process. If I can, hold on. All right. So I'll narrate a little bit here. So in order to help illustrate how transcoded playback works, some of the prelude here is I'm going to actually simulate a mobile connection by switching down to a 3G connection in my browser. So we want to be able to watch these two videos side by side on a crappy 3G connection. And that should help illustrate why transcoded playback is useful. So we've switched it over to a 3G connection, and now the first thing I'm going to do is I'm going to try to play back a particular CID for an MP4 file in an IPFS gateway. So it's going to take a little bit to load, and there you go, and we start playing, and boom, we have a little bit of buffering. So the playback is starting to stutter. So this is actually what you would expect to happen when you're on something like a 3G connection, because if you have a higher res video like this, you're just really not going to be able to download data fast enough on your bandwidth, regardless of what's happening on the infrastructure side, if all you're dealing with is that file. So what we're going to do next is we can go to that demo page that I talked about. We're going to take that same CID, and we're going to create an IPFS URL using that CID, and we're going to try playing that back. Give it 1 second. Cool. So there we go. We entered the IPFS URL with the same CID for the same video file from before. And we're going to press play. We wait a second. And now playback starts. So if we wait a couple seconds and let it play, what we can see is that we've started playing back the video, but we actually don't have any buffering anymore. And this is because we're actually watching a transcoded version of the original file, and that was produced after pulling in the data from the CID and then making available the transcoded renditions in this player afterwards. So hopefully this demo can help illustrate to you what the feature looks like, and under the hood what's happening is that we've created a simple JavaScript player that's compatible with React applications, and it can take care of this all for you. So all you need to do is, if you have existing CID references in your app, you just drop it in with a couple lines of JavaScript code, and then you can enable an experience that looks like that. I'm running a little bit low on time, so I won't show the next video, but this video here also illustrates the same concept if you're using another storage network like Arweave as well. So instead of using IPFS CIDs in order to play back, you can take an Arweave transaction ID for an existing asset on Arweave, pull it into the video compute pipeline, transcode it, and make it available for playback, and it works the same. But I'll skip over the demo video for now in the interest of time. If anyone is interested in that, come talk to me afterwards. Cool. So what I'm going to wrap up with is taking a step back. I just talked about this IPFS CID video streaming playback feature, but I think what's interesting about that feature is it represents a step towards what we like to think about as the decentralized storage video compute pipeline. And what we mean by that is that transcoding is an integral part of internet video. However, it's not the only part of video on the internet. There's other things and other ways that you can enhance the video experience. So one question is, what other forms of video compute could be interesting? And this is not a comprehensive list by any means, but hopefully this can start illustrating some of the exciting things you can do from the point of view of experience. So some people here might be familiar with OpenAI Whisper. So Whisper was a model that was a machine learning model that was released by OpenAI recently. And what's cool about it is that the Whisper model can take in an audio stream, parse through it, and basically create a transcription of the actual content within that audio stream. And someone actually did this for the Lex Fridman podcast and took all the Lex Fridman podcast audio streams and transcribed them and created these captions files. And what's cool is that from those captions files, you can actually insert those as metadata tracks in videos. And then now all of a sudden, that auto captioning feature that you have on YouTube, that only YouTube has, you can have in your application as well. Something else that I think is pretty cool is, if you recall when I was talking about the Rickroll example, this technique called super resolution. So super resolution is an image restoration technique or a video restoration technique where you can upscale and increase the resolution of a video after the fact or an image. One of the more popular ways to do this is using this open source model called ESR-GAN. And on the left, I actually have an example that shows a video that I created on the left, and then the ESR-GAN super resolution version, which is larger and is more detailed. So those are two examples of additional types of video and compute that can create these enhanced experiences. An additional thing that's worth mentioning is if a lot of people are on Twitter or follow the latest trends in AI, then you should be familiar with things like Stable Diffusion and generative models. And these models are super cool because you can actually, instead of having video coming in and video coming out, you have text coming in and video coming out. And you can actually have machine learning models and neural networks actually help generate the content, and you can create videos from that. So the image or the video that I have on the right is actually, there's no music here because I don't have audio hooked up, but this is actually a music video that I created with Stable Diffusion using this Stable Diffusion videos repo on GitHub. So this is a video that was created by taking two text prompts and then using text prompt number 1 to generate a starting image, text prompt number 2 to generate an end image, and then using the Stable Diffusion process to interpolate those frames and generate the frames in the middle. And then you use a video concatenation technique in order to stitch everything together, and then you have the video. And under the hood, what's happening is there's a lot of standard video and image tools that are being used to create this in addition to the actual generative process. But those are all things that can be a part of this video compute pipeline that I just described. So this is a visualization of what this compute pipeline could look like and can look like. So I won't go through this in detail, but what this illustrates on top is a pipeline where you can have video input come in and video output come out. And you can also have a pipeline where text inputs come in and video outputs come out. And just some of the examples here include you can have a video input come in, you can decode the video, you can scale it, you can transcribe audio, you can encode it into a new video. Or on the bottom, you can have a text input come in, you can have a text to image model, create the actual images. You can use a concatenation filter in order to concatenate them all together, and then finally you encode that into the end video stream that you distribute. And those are just some of the examples that you can enable with this compute pipeline. And what you'll notice is that the commonality between all the different pipelines here is that encode box at the very end. And that's because if you're wondering why there's an encode box at the end, well, it's because, kind of going back to transcoding is composed of two parts. You have a video decoding part, and then you have a video encoding part. And you are going to do video encoding every single time that you need to produce a video that needs to be transmitted online. So basically, anytime you have a pipeline that needs to create video, you're going to do half of the transcoding process no matter what. So all of these pipelines are about creating videos, whether they came from another video or a piece of text or an image. And these are some of the types of things that we think people can get creative about once we enable this type of video compute pipeline. And all of this can remain rooted in CIDs. So CIDs remain the root for the pipeline. CIDs come in, the data passes through the pipeline, and you get new enhanced renditions on the other side. And what I'll end with is this notion of verifiability. Ideally, in an ideal world, we can end up with this situation where it's verified inputs in and verified outputs out. So in a world of many formats and renditions of the same original video, given a verified input, whether it be a CID or some signed piece of data, how do we link the video output of the pipeline back to the input? And that's something that we think a lot about at Livepeer, especially in the context of this video compute pipeline. I won't get into too much like some of the work that we've been doing there, but some of the things that we think are possible here are basically trying to create these provenance chains and audit trails for the computation in one of these video compute pipelines so that you can actually get verified output out given verified input in. If that's something that you're interested in talking about, happy to chat more about that separately. But to close out, just want to summarize some takeaways from this presentation. So the first one is that CIDs and cryptographic IDs are really interesting because they can serve as standard references for videos. And that can then be enhanced with video compute pipelines on decentralized storage, which enables developers to build experiences around video content in a permissionless manner. The IPFS CID video streaming playback feature that I demonstrated is one way where we can enhance, by creating transcoded renditions, a CID by creating new types of data from decentralized storage data. And lastly, this general approach of decentralized storage video compute pipelines to create enhanced video experiences we think is particularly interesting because it allows you to apply different types of video compute on top of decentralized storage. So that's my presentation. Thanks for taking the time to listen. And if you're interested in any of these topics, happy to chat further afterwards, or always happy to have people join the Livepeer community via this QR code. And that's it for me. Thank you.
Thank you, Yondon. Questions? I should give you a microphone for always.
Hey, that was awesome. That was really cool to see the transcoding and so on. So I understand correctly, that's in a JS HTML5 player already. Have you also considered doing like a gateway? So you could have a gateway, because there are a lot of like simple HTTP clients that can't run JavaScript or something like that to reroute the request. Have you considered doing like a gateway so you have like an actual service that just does all the transcoding ahead of time?
Yeah, so what's happening under the hood for that is all the transcoding is happening. So the demo that I demonstrated, you have to first pull the data in, and for the purposes of the demo, I did that before doing the demo. So you would always have to do that first, wherever it lives, you have to pull it from the gateway and then transcode it and then make it available. What the actual JavaScript code does is it's just a wrapper around some of the open source HLS libraries, because we're doing HLS transcoded playback, and those are pretty standard already, and we just have some like syntactic sugar on top so that I can understand a CID and then translate that into the format to send it to the API to then pull the data, make it transcoded, and make it available for playback. I'm not sure if that answered your question, but okay.
Can I ask? Is it okay? Do you want to go first? Cool, super cool tech. I'm curious if you consider like using all of this for remote gaming, right? Like with NVIDIA's DLNA and AMD's FX, where you could just like enable people to rent out their GPUs so that other people in the network could like play video games and use Livepeer network to stream that video, but then like upscale it when it gets to the user's machine.
So that's a really interesting and exciting use case, and would love to kind of explore the technical approaches required to do that. One of the main challenges there are that from a network design standpoint, like we've spent a lot of time making sure that the way that the pipeline is structured is that it can handle failovers particularly well. So if you're in the middle of transcoding a particular chunk of video and there's a failure in any point in time, if you fail over to another node on the network, it has minimal disruption on the actual end streaming experience. For something like the rendering cases that you mentioned, that type of like failover for those compute workloads might work as well. I don't personally understand it well enough at this point in order to say, but those are one of the big challenges that I think we would need to address, where because it's in this distributed network and any of the nodes could fail at any point in time. And with gaming, it needs to be this really slick experience the entire time. And if you have to do some of these like rendering jobs on the fly and some of these tracing jobs on the fly, you would have to kind of adapt those workloads to work in this type of environment as well. So I'm just honestly not sure what that would take, but it would certainly be interesting to look at.
Awesome, thank you.
Hi, thank you. I have 2 questions.
Sure.
I missed a little bit at the beginning, so I don't know how well this supports live streaming, but how do you handle tail-end latencies for people? And also, have you considered transcoding on the edge or doing some kind of transcoding on the fly?
So we do support live streaming. This presentation was primarily assuming that you have like a file somewhere and you want it to be transcoded on demand. We do support live streaming, and the actual transcoding workflow looks pretty similar, but what's different is that instead of having like a static file that you would upload, we support right now the kind of most common like ingest formats for live streaming, so both RTMP as well as SRT. And instead of uploading a file to an API that would route it to a node on the network, you would instead take OBS or one of these broadcasting tools, and it would create an RTMP or SRT stream, and that would be ingested directly by one of the nodes. So that's on live streaming. Transcoding on the edge, that's great question. So we don't do that right now. The transcoding happens basically wherever the nodes on the network are. Something that we do think is interesting, and especially with the rise and development of these different decentralized CDN projects, is, well, transcoding is one thing, but something that we know that we would definitely be able to do that a lot of traditional certain traditional CDNs do already, is what's called just-in-time repackaging of video on the edge. So some CDNs actually offer this as a feature where they will not only serve the files to you really fast, but they can dynamically determine what file format you need, and they'll repackage it on the fly for you. And that's actually, the nodes on the network do the repackaging as well, in addition to the transcoding. So that's definitely something that I think would be interesting to explore with projects doing decentralized CDN stuff in the future, because I could definitely see a future where we can support that faster and also just better than some of the traditional methods right now. And transcoding would be a little bit more tricky, but would have to kind of figure some more technical things there out.
Since you mentioned it, where does the manifest get created for these streams? Like, how does the player negotiate what channels or what streams to pull from the transcode so it knows whether it's HLS or Dash or whatever?
So the architecture is that we have 2 different types of nodes on the network. One type is the orchestrator, which actually does the heavy lifting of transcoding. It actually doesn't need to know the end format that the client requests. And then on the other side, we have these broadcaster nodes, which you can think of as like running a full node in the context of like a blockchain network. And the broadcasters are responsible for basically routing these jobs to the orchestrators, repiecing it together, and then based on what the client needs, they can generate the HLS manifest and make that available to the client, or they can also make other decisions if you need something outside of HLS, but HLS just happens to be the most common. So usually it just does the master playlist generation, and then the client is able to fetch it from there.
One last question. Have you ever any trouble with cores? Like, I'm not sure if this is a Web 2, Web 3 problem, but like basically origin support of the browsers. Is this something that's an issue at all?
Cores, definitely. I mean, I think early, so when we started working with hackers at hackathons, there were cores issues all the time. And that's something that, like, we have some like temporary workarounds where you can basically create like certain types of API keys that get around that. So like short answer for now is like yes, and can elaborate more separately, I think.
Hey, have you thought about creating marketplaces for the different compute pipelines so that other developers could build on like the compute pipeline?
Yeah, so I think that would be a part of the that would be a part of the vision here. Where right now, like transcoding on the network is just something like the core team is like baking in. But I think it would be pretty interesting to be able to have a larger marketplace for being able to run different types of filters and compute tasks in the middle of the pipeline. The best analogy to this is if anyone has ever used FFmpeg. FFmpeg has this nice filter graph system where there is the standard set of filters that are implemented for FFmpeg, where you can do stuff like scaling, frame rate adjustment. You can even do deep neural network inference. But you can always fork FFmpeg and add your own filters as well. So I think that's a good analogy here, and I expect the way that we would get started kind of building out these types of pipelines is working on the first few with the community directly, and then from there identifying a good framework with which you can have more flexibility in inserting your own things into the pipeline as well. I think the most important thing there is just making sure it can like slot into the pipeline as well, because we need to make sure that it can consume the right type of content and output the right type of content and continue in that chain.
Thank you, Yandon.
Cool.
Thank you for all questions. If somebody has more, you can ask later directly. So now our fourth speaker, Evgeny Ponomarev, co-founder of Fluence. Welcome, Evgeny. Applause.
Should I move it? Should I? Does it work? No.
You have to pass the things to this.
Yeah, I'm trying to see because I have only one screen. It's so weird. I guess I see only one desktop.
You wanna try with another laptop maybe?
No, it should be. It's gonna be the same. Maybe. You see, I have only one screen here.
Что произошло?
Ну, типа у меня один скрин только. И непонятно, как его туда показать. Не показывает.
Да.
А так не показывает тоже. Так тоже не показывает. Мне кажется...
Подожди, а ты прямо перенес? У тебя только два экрана, а не три?
У меня один экран вообще сейчас. Мне кажется, надо, может, переходник другой.
Подожди, а вот тут что можно выбрать?
Ничего нельзя выбрать.
Вот смотри, как будто два экрана, вот оранжевый.
Где?
Вторая вкладка. Да, вот здесь нельзя выбрать. Вот, да.
Okay, nice. Okay. All right. Hello, everyone. I'm Evgeny, co-founder of Fluence. Thanks, everyone, for coming. I'm gonna speak a little bit about what we do at Fluence, and we do decentralized computing. So this is like pretty obvious introduction. You know, if you hear for the WebFree week, you probably believe in WebFree and decentralization. So in general, we kind of see the movement from personal computers to clouds and like to decentralized platforms in general for a lot of different tasks. And we sort of like succeeding in terms of decentralizing the financial system with all the blockchain stuff and crypto and smart contracts. And we are like, you know, halfway there with decentralizing internet infrastructure, with storage, with like IPFS, Filecoin, RVF, and other guys. We see a lot of, you know, projects semi-successful around identity, and, you know, and I just wanted to talk specifically about what happens around computing and how we see like the future of decentralized computing. So basically, if you think of computing like a blockchain is a big part of this industry because that's the new way of doing computations. It's a like very expensive, very constrained way of doing computations, but they were created for a specific purpose of reinventing money and like financial instruments. That's why they have this very specific design of having consensus and having all the nodes in the network keeping the same state and exchanging the data and having consensus for every new transaction, state transition. So that this make them expensive, but like good fit for financial use cases. There also were several attempts in terms of like trying to do some general purpose, more like traditional computing, but decentralized. But they were mostly focused on batch tasks, like on heavy computations, on like a massive computing tasks, like for rendering a video, like or scientific computation, stuff like that. And we were trying to understand, like, if it's possible to find some solution that would allow us to, avoid using traditional clouds like Amazon, Google, like at all. So whenever we build any application, or web application or mobile application, like something that our basically internet consists of, can we not rely on proprietary and centralized infrastructure at all in terms of software and in terms of hardware as well? The point that that's a long concern for people who ever build anything in Web 2, that you usually want to build you want to create some new application, some new business as fast as possible. Then that's why you want to rely on some tools that provided by other companies and built by other people, especially in the form of APIs. But then when you use these APIs, you're basically locked in into proprietary databases, like proprietary companies that own these databases that provide API. And then like they control the access of yours to their API. And then if they don't like you anymore, they can just cut the access at any moment. And your application just stops working. And you have really no control over it. This happened to Twitter, it happened to Facebook, and a lot of such cases in Web2 space. And also, like on the infrastructure level, you don't want to be locked in into a particular cloud provider. And there's a lot of stories that, like, even if people were happy with some cloud provider, were happy with the pricing, with the tooling, but when their business starts growing, the pricing may not be good enough, but they already created so much things on the proprietary stack, so it's too expensive to switch. So people paying, like Amazon, a lot of money, especially when their business grows, but it's just, at the same time, it's just too expensive to rebuild everything on the other cloud, so they never switch. Like sometimes it's just very painful. But in Web3, we have actually, like in Web3, we have kind of solved the data access problem by putting a lot of stuff on blockchain. So we have like thousands of replicas of the same databases. So like potentially we can connect to any node and get the data and be free from vendor lock-in. But in fact, a lot of people basically, like, because in particular case of blockchains and blockchain data, the data is organized on blockchain nodes in a very specific way that usually it's not very convenient for doing some queries or particular data extractions from it. So people create APIs on top of blockchain data, and these APIs are basically like some code sitting in traditional cloud, and it's centralized. So whenever you use that API built on top of blockchain, then you also subject for this vendor lock-in. And there's a lot of like things. There was a story about Tornado Cash a couple of months ago. There are interesting stories about, like, if we have, even if we build DAOs that supposed to, automate the the ownership and management of the Web3 applications. But our Web3 applications are only partly can be enforced. Their updates or their changes only partly can be enforced by DAO decisions because the applications themselves are not fully on chain. There are obvious limitations of the chain, so you cannot put like the application fully on chain. There is always some smart contracts on chain. There are always some backend sitting in the cloud in Amazon doing some indexing, API, user data, and stuff like that. And there are a lot of interesting stories, like when the DAO makes a decision, you cannot really enforce the code sitting in Amazon to follow this decision of the DAO. So like if the DAO wants to update the off-chain application, that's actually not really possible to do directly. You need to bring someone who is admin of this Amazon account to go to log in and to roll out the update after the DAO made a decision. So you have this disconnection, which may lead to like really just the DAO, like managing applications by DAO just doesn't give you its real value in this case. Yeah, and again, so this is the point about like APIs that built on top of blockchain data. There are like many of them. There are NFTs APIs, like APIs for the wallets, DeFi APIs and stuff like that. And like if you build on it, you have again the same problem. You're subject of the lock-in, and the access can be disabled, even if these guys are cool and great and they're in Web3 community. They can change their mind, and you can, if you build on their API, you can lose your business. So there would be super cool if you can build like really decentralized APIs that really don't have centralized gateway to access them. So the way we see kind of how to solve it, like we need some sort of peer-to-peer decentralized computing that would be somewhere between centralized computing and on-chain computing that would also will have no middleman, as blockchain, but will not have redundancy and like cost, like high cost, like on-chain computing. And it's basically like super useful for many use cases, like blockchain use cases, like general purpose Web3 use cases, like messaging, social network, whatever. It's like very friendly with the DAO. It has some, may have some even use cases that haven't existed before, like for example, like the Filecoin example with the ceiling computing job, which you want to probably run on decentralized infrastructure instead of centralized. So, and we approach this with Fluence, and the best way to think of Fluence is it's analogy of the cloud, but it's analogy not of the like all cloud services, but mainly analogy of serverless stack of the cloud. So basically, to enable this serverless stack, we build a development platform with all the tooling. We build a network where this development platform runs, and the network is the open marketplace of providers. Anyone can join, anyone can run a node, anyone can be provider on this network and be part of development platform. And it's all kind of works together with the economic model. So development platform is basically I can skip it. So if you're familiar with the serverless stack, it's like cloud functions, workflows on top of functions, so like Amazon calls them step functions, and there are a lot of tooling that allow you to to have the scalability and performance of your application. And we kind of build the analogies of these tools. So we have the WebAssembly runtime, which allows to deploy and run WebAssembly pieces of code as a functions, basically. We built our own tooling for the distributed workflows that can orchestrate this execution of the functions. And we we try to enable all these simple pieces that allow you to build whatever backend business logic you want. And the workflow part is important because we are trying to, like, when you build the more or less complex backend, it always contains from some pieces. And if you want it to scale, you end up with this design that contains of two things. You have the piece of code to execute, and you have some business logic on top of several pieces of code and how they work together and what happens if something fails or you need to parallelize something and stuff like that. And usually in the cloud, you have this design. So you have a centralized API gateway where all the HTTP requests from the clients come, and then this gateway orchestrates the request to a bunch of microservices. And it all works perfectly, but the problem is someone needs to own and run this API gateway. And if you want to if you want to avoid this gateway, then we need something very different. So, and what we created is something that works very differently. So that's the basically protocol and the programming language that allows you to create and run any distributed workflows or network algorithms. Like this one, for example, this example, this is a few lines of code where I can say, I want to take the request from one user, and via some relay node, I will parallelize the execution of some function on several nodes, and then I will ask them to send the result of execution to like another node and calculate the average and send the result to the second user. And I don't have any coordination or like a gateway here where I need to, which keeps the list of nodes or which keeps the list of like the order of the execution. So this script is basically put into the data packet that initiated by the first user, and every node has the runtime that can parse this script and see, okay, I need to execute this part, and then I add the result to the data packet, and then I send it further. So basically, like Fluence network consists of such nodes that contains the runtime of this Aqua language. They contains the WebAssembly runtime to execute functions. They may contain plugins with the data networks, like with storage networks, with like external. They can access external world, like via legacy HTTP calls. They can access blockchains and stuff like that. So basically, on any node, you can run a function that can take data somewhere, do some work, and put data somewhere else, or put data to the output request. And the experience of it, like it's very similar to the serverless stack. So you have functions, you can schedule them, you can call them, and they are event-driven, and you can run workflows on top of it. But in terms of pieces that require to achieve the proper developer experience that we used to in legacy cloud, a lot of things still kind of missing. So it's not yet at the moment where it's just magically automatically scales or load balances or does stuff like that. But it's something that just we need to build as a part of the platform, and which will be built as a part of Aqua language as a like libraries of the language basically. Yeah, and again, like some basic features available already, some like data adapters available already, and a lot of things that looks more familiar on the level that you used to see in the cloud tooling is kind of still work in progress. But the cool thing is, like Aqua is basically a DSL that allows you to quite easily to create coordinator-free algorithms such as like failovers or balancing or like subnetworks, consensus, and stuff like that. So it's a very nice and developer tooling that is like targeted for creating distributed algorithms, so you can create whatever algorithms you run on the backend. And very important topic about secure model of all of this. And basically, like in blockchain, by default, you have security model of the consensus. So basically, like you have some computation, you deploy it to a network, and then every node has to repeat it, and every node has to get the same result. And that's why it's so expensive, that's why it's so slow, and stuff like that. So Fluence by default does not apply consensus on the computation. So like by default, it's basically trusted computation right now. So you deploy a function to the node, and then you trust that the node executed it correctly. There is a thing called trust graph that we have, which is something similar to the concept of web of trust. It means that if I know some authority and this authority trusts this node, then I maybe should trust this node because like it's like some other people saying it's trusted. But obviously that's not enough if you want to have like proper verifiable decentralized computations. And what we're allowed to do is to like it's optionality. So like if the consensus based computation is fine for you in terms of cost and performance, you can apply consensus to execution of some function, and you're going to have, you know, basically several nodes saying, okay, this or the result of this function is this, so you can trust the result of the function. But more exciting thing that we are working on right now is the probabilistic and zero knowledge proofs of the execution. And the goal here is that the Aqua are going to have the proofs of the correctness of the workflow execution, and the Marine, the WebAssembly runtime, going to have the ZK proofs of the basically like a WASM execution. So in the future, it's not now, but like in the future, you will be able to run to use Fluence the same way as the cloud. So you can run on just one node, and then you have all the proofs that this computation was executed correctly, and you can like basically trust this, and it's much cheaper than when you use consensus because there is no redundancy. It depends a little bit on the ZK proofs generation, but like there are ways to optimize this stuff. It's like this area progresses pretty fast now. Yeah, so basically like this development stack runs on the network, and the network is heterogeneous. Basically like every node is different. Every node is a hosting provider, and like every node runs different functions wherever it allows to run on their hardware. And yeah, so if you have such a network, if you have such development stack, we can really build applications and APIs that can be not really can have similar capabilities like applications on chain, where you have this separation between author of the application who creates smart contract and the network that runs the application. It's like if for example I have basically blockchain have this feature of forking, right? If some part of network disagrees with update that developers pushes, the network forks. And here you can have such sort of application forks. Like if I run some application on some nodes in the Fluence network, and then I want to create the update and deploy the update that the users don't like, the users can say, okay, like we are forking the application, we keep running the older version on the nodes that it was available before, and the new version maybe will also be adopted by some other nodes. But that creates a lot of flexibility. So in terms of like, if there is a version of some application that has demand, the user demand for it, it will exist while it has demand. So like while some people are ready to pay to nodes for hosting this version of application, regardless what the original author of this application thinks or does, this version may exist and may be available for users. And this is some state of things. So we have the network up and running right now, and you can do some basic stuff with that. We want to have the DAO, make the network to be governed by the DAO. Should come this year, but with this market we kind of not sure yet. And we work a lot on the all of these incentives and the economic model and the proofs, because like it's all connected. Like the proofs of computations is tied to reward for the computation, because we want only pay to those nodes who executed the code correctly, and that's why we need the proof of computation for enabling the payments on the network. We don't want to rely on just reputation. Yeah, so like the economics is very interesting topic, because you can not only just have the payments for computation, you can play with this a lot of on-chain primitives to like enable even some sort of DeFi on top of computation workloads and stuff like that. And there are several other interesting things here that can be enabled. For example, the whole thing runs like a decentralized open cloud where there are compute providers, there are some application developers, and there is some the economics of it exists on chain, so it's kind of transparent. You can see which applications, how much money pay to which compute providers, and which pieces these applications consist of. And this allows us to enable one very interesting thing. So in current clouds in Amazon, like for example, there are databases, like open source databases, which being used by millions of developers. And the authors of these databases do not really get any money from Amazon from the revenue they generate on their creations. And this is kind of the big problem, because it's disincentivizes to build open source, because like if your open source is popular, the cloud's gonna adopt it and they're gonna extract all the money they can, and they are not really incentivized to pay you anything back. And here we can enable, like, because we have this link between where revenue goes and which pieces of applications generate revenue for the nodes, we can extract the small part of this revenue stream and send it to the authors of this useful pieces of applications, such as database or like maybe like libraries, stuff like that. They've been reused across different applications, and you as an open source developer can like really continue building the open source product and get a fraction of cloud revenue, which is super cool. Yeah, so this is just a link to some network dashboard. Like it's still kind of, you can call it testnet. So it's still kind of work in progress, but it shows something that happens on the network. Yeah, and that's it. So basically, there are some communities that we have, and obviously we are hiring. So if anyone interested, feel free to reach us out. That's it.
Thank you, Evgeny. It was very nice. We have a question, yes.
Thank you. Yeah, I just had a couple of questions. It's short. So for the first question, what is the scalability right now for this? Like, how many people can you support?
Yeah, so right now the network is like pretty small, like because it's non-incentivized network. So if you know how IPFS network looks like IPFS is non-incentivized network for storage. Basically, like a Fluence is a similar model for compute. So like you can run a node, but because you're not earning money for running a node, there's no point to run a node. Like the only point to run a node if you build the application yourself and you run it for yourself. So we, as Fluence Labs, we're running like a bunch of nodes for community. They are quite reliable, but it's not a huge network at the moment. So like for us is the moment of scaling the network is the launch of the economics and payments.
Okay. And so the second question I had, because you mentioned how if the users want to continue to support an application, it'll cause a fork. So one thing that popped in my head was, like, as far as like support of that, like let's say the users do that, and they want that application, and you come up with the new version, and the fork, they continue to use the fork, but the developer doesn't want to support that fork. They want to keep going with the new. How does that get resolved?
Yeah, I mean, that's a long discussion, but to me, it's important that it's a optionality that you get. Like, if developer doesn't support, but the application is fully built on Fluence network, it's probably going to be open source. And if it's open source application, then these community members that were like believed in those version of the application, they may continue development, but they may not happen, and it's okay. But the point here is that the API to the previous version application is always available until there is demand for it. And this way, if you build on some decentralized Facebook API, and then they decided to cut access to someone in the new version, in the old version, you will still have the access. So that's about like where you have the access to. And
Thank you. More questions?
Thank you. So I have a question. What's the motivation for using WebAssembly as a language for your runtime?
Well, it's just, we believe in WebAssembly in general. We think that it's more secure, better sandboxed, faster to start, lighter runtime. And basically that's the that's something that's just gonna scale better and it's gonna be adopted everywhere.
Okay, thank you. And follow-up question: is it possible to run a closed source application on Fluence? Like, do you support bytecode runtime, or is it like source code interpreting?
So basically, there is a way to, if you don't want to disclose the code of the application like at all, there is a way to do it if you run your own node. And like, well, it's gonna be like centralized setup, because like, if your code sits on your node and the only way to access to kind of run it is to access to your particular node, then it just like no one sees the code, but at the same time is centralized.
But can you maybe just share a bytecode, which is kind of like, can nodes just run the bytecode not knowing the source code of the programs?
It can, yeah, it can. Well, it can, but if the node runs something, it can, if it wants to know what's inside, they can scan memory or stuff like that and try to guess what's inside, but not the source code, but like still understand what is happening there.
Thank you.
Hi, thank you. This is very interesting. So my question is, have you thought about distributed scheduling in the Fluence network, for example? And the second question would be, if you have distributed scheduling, then how have you thought about optimizing data paths among computations?
What is distributed scheduling?
Okay. Fine.
Well, but we can, actually, there's a Dmitry and Bernard here who can maybe know the answer to your question.
Okay, just to give a little bit of perspective, is what I mean when I say distributed scheduling is, so I, as an application developer or maintainer or whatever, provider, I think that's the word. So I want to provide my application in the network, right? So now my application has different computations, like each of the marine things that you talked about, right? Now these can run either on a single node in the network. Let's say this node can be a random node, or it could run on multiple nodes, right? And we can make this problem as complex as we want if we think about where the data comes from, right? So when I'm saying distributed scheduling is I need to choose a place for these computations to run. That's what I was meaning by that?
So if the question is like, how do I know where to put my computation and how to, schedule the execution? So we kind of think that is, there are two ways, there are two approaches to do it if you're application developer. Like ideally, you want to just pick something, some, practices or templates or something that says you, okay, for this function, the fastest node will be chosen for this particular user, or like, something that is pre-built for you. Or you can build the whole custom workflow in Aqua based on whatever you think the needs of your application. I'm not sure if it's...
Okay, so in my application, I would tag the computations in a way.
Sort of, like you can express, so you can, in your application, you can have the Aqua workflow that would describe how the computation should run, and like where it should be deployed. You have full control on where it's deployed and how it runs in terms of function calls.
Okay.
And you can schedule this stuff as well. So you can deploy the you can deploy the function. You can schedule the function on one node, then you can deploy the function on another node and schedule as well. And then if these functions, and then you can have the workflow that connects these functions, for example, to replicate data between them. So this way we'll have the peer-to-peer replication, like data replication protocol. So you basically write these workflows to deploy stuff and then to ask this stuff to run.
Okay, so the user has full control of where things are. Okay.
Yeah.
Okay, thank you. Thank you.
Okay. Last question.
Thank you, Evgeny, for presentation. I think I'm not actually full understanding how Fluence still work. But my question is about on slide with the ZK proof. Yes.
This one.
Yes. The proofs of compute. How it works actually? It like optimistic that I just calculate it and push result of this to network, and if somebody don't like it, they ask proof, ZK proof, and if nobody can give this proof, they have slashing, or not, or maybe
it's a little different. So there are two parts of it. Like Aqua proofs right now, the design that we're doing is that because Aqua, like there are a lot of Aqua is basically requests, right? Like the same as HTTP requests, but going on over peer-to-peer network, and the network serves potentially like billions of requests. There's you need to find a way to generate either very light proofs for every of these requests, or you have some probabilistic algorithm that would allow to only check, once per 10 requests and see if it was correct or not, and then to reward the nodes if they serve correct results. So for Aqua, we do probabilistic proofs. So it basically means that in order to withdraw the earnings, the node has to, there is a like algorithm of choosing the particle, this request that the node needs to submit on chain where it's going to be verified. If the node submits incorrect particle, it got slashed. If it's correct, it can get money. And there is the marine proofs, the WASM proofs. We're still kind of like researching this stuff, but the idea is, ideally we should have the ZK proof on every execution, because this code can do like some state transition and stuff like that. So it's dangerous not to have proofs on every execution. But you need to optimize. You can have ZK proofs for like basically running every instruction of WebAssembly virtual machine, but you want to optimize it so like you can there are ways to optimize it. Like you can do like a zk proof for like every 10 instructions of virtual machines and stuff like that.
Okay, you call it probabilistic, yes?
Yeah, so it's sort of
Okay.
like mix of probabilistic and ZK.
Okay, right now I got it. Thank you.
Thank you, Evgeny. Thank you for the questions. Thank you all speakers. Now we will have 5 minutes break for refreshments, and later we will be still here for panel discussion, which will be leading David Aronchik. Oh, sorry, Aronchik. Yeah. So we have 5 minutes, and we will meet here.
Okay. We have 4 for stage, and then we have 1 extra for the audience. That one is the audience one. You don't need the audience? Okay. Fazemos só os micros 1, 2, 3, 4. Não, é aquele, mano, é aquele, eu disse sim.
share, yeah? Hey guys, let's come back. We will have panel discussion now. Thank you.
Okay, let us get going. Well, thank you all so much for coming this evening. We're now going to have a quick panel on all the fine speakers we had tonight. Justina, Vuk, Evgeny, and Yonda. I'd like to start with Justina. We have been making so much progress in Web3 and really advancing the state of the art, yet there's still obviously a gap. Beyond just the stuff that all of you are working on, what do you think the biggest thing holding us back is?
I think there are a few things here, really. I'll try to make my answer as short as I can, but I think one of them is that in general, like tech has to improve. It doesn't really apply to ceramics specifically, but in general, applications that are being built in Web3 right now, I think I mentioned that in my talk as well, that most of the things that I've seen so far are really good in terms of financial standpoint. It's great, like there are so many opportunities from DeFi and all of that stuff. But then when it comes to making that leap to build applications that are more user-centric, that have lots of features and so on, we are really not there yet. And the key reason, at least in my opinion, is because we don't really have good solutions just yet to how data can be stored, how we can do the computing and things like that. So I think all of these projects that were giving talks today, I think they're great examples of how many exciting things are happening. And I think the future looks really exciting, but I think we really have to make that shift. And another one, which I think is overall a really interesting idea, is that a lot of times we speak about what kind of things we have in Web 2 and how we can make the same thing in Web 3. I was at DevCon a few weeks ago, and it was actually a talk from Livepeer that I heard, and they mentioned a really interesting idea about that, and they said that the real breakthrough will happen when someone will build an app that is not only better than what we have in Web 2, but that doesn't even exist in Web 2. So I think we really have to keep thinking bigger, and instead of just trying to replicate what we have in Web 2, which is obviously great, we really have to think what's beyond that, what Web 3 can really give us in terms of applications, user experience, and things like that.
Cool. Vuk, kind of extending the answer, like in infrastructure, is there an opportunity to extend beyond Web 2 to something truly transformative?
Yeah, I think there are a couple of things here. So one is definitely having infrastructure that is at least 30 times cheaper than with centralized cloud providers. And the reason for that is that AWS and big tech companies are just greedy. Like there is no reason for them to keep prices that high. And of course, like they are basically building monopolies on top of like the users. They were using other services. They just sold the VMs for much more higher prices. But on the other hand, like I think what's holding us back is the fact that we are really not collaborating enough. If you think about what happened in Ethereum, most of yeah, sound is better. Most of the innovation came from the fact that you had different smart contracts interacting between each other. And if you look at computing and what we're doing today, we are really not doing that. We have a bunch of computing networks all doing one particular thing, which cannot by itself be better than what cloud providers provide. But if we combine multiple networks and we have workloads interacting between each other, then we can actually do things that were not possible before. Imagine having a Zoom application that is decentralized, and then having the ability to have a bunch of filters that are built by an open network, where you have a marketplace where people can actually decide what kind of filters they want. Maybe that is a super smart way of removing your background. Maybe it's a way for augmenting your background on what people are talking about in that particular Zoom call. So those are things that are not possible today, and opening up the market both for developers that can build those backgrounds and filters, but also for compute providers that can run those and earn money for doing those, and then reducing further the cost by 30x. That's something that definitely is not possible today.
That's great. So, Yanin, not to put you on the spot, but Justina mentioned that you were already looking beyond this. Vuk mentioned that there are already a lot of monopolies out there. Why are people buying into it? Why are people going and buying on AWS versus taking a choice on something that is decentralized? Is it just missing pieces, or is it something else?
So, great question. I think a big reason is in the status quo and in the status quo of development. It's just really convenient, and it's really convenient to default to known quantities, and AWS and cloud service providers are known quantities. And I think that is a hurdle that can eventually be surmounted by a lot of the infrastructure that's being built in this space. However, kind of coming back to the first question that you had around kind of what is the gap that exists and why aren't we seeing more application development on this infrastructure? On one hand, I think it is important to make the tech quote unquote ready, and it's really important for infrastructure builders to continue pressing forward there. At the same time, I think it's important for infrastructure builders to work hand in hand with app developers, even when that's not the case, and work with the app developers that are especially taking alternate approaches, sort of to what you were alluding to before, where we definitely lead better versions of the Web 2 applications that we already have today. However, I think there's a huge opportunity to take a different route initially as well and identify what Web 3 and crypto actually can uniquely enable. And because it's unique and fundamentally cannot be achieved with Web 2 applications, there is room for there to be a gap on the infrastructure level. And then that allows the applications to actually drive the roadmap of the infrastructure, because the applications are demonstrating, oh, this is a clear use case, and this is clearly something that infrastructure and Web 2 cannot do. So it makes total sense for you to improve on it. I won't take too long on this, but the one example that I really like is some of the stuff that we've seen in the Ethereum ecosystem with this game called Dark Forest that some people might be familiar with. But it's this real-time strategy game where, without even getting into the internals, it's based on zero-knowledge proofs. But when they first launched it, people thought they were crazy, because they were just like, Ethereum can't scale today, and you want to do this on Ethereum? And they were like, well, we're going to try it. And what was cool was the game was unique enough such that people were willing to go through some of the hurdles that were there at the time in order to continue playing that game, and that actually helped accelerate a lot of the R&D in the right areas in order to make that game more sustainable. And 3 years later, it's still going. And is it at the scale that we want it to be at? Not quite yet, but I think it's a great example of how if you take this alternate path and really focus on what's uniquely enabled in Web3, you still want to support the other use cases, but this is a way to have the applications drive the infrastructure progress a little bit more.
Fair enough. Evgeny, you're out there building the entire thing, and then there's some realities of physics, right? Speed of light, decentralized compute, things like that. Will we ever have a one-to-one match with infrastructure from Web 2? Do we need one?
Well, I think it's also a good question. I think some of these pieces definitely we just need better, evolution of them in Web3 space. Some of these pieces just will. Well, I think a lot of this it depends on the scale, right? Conceptually, things like I want to run some code on some infrastructure that magically runs and magically scales. I don't want to think about how it works under the hood. The need for it exists in Web 2 space and the Web 3 space, but the need in very particular solution, like how this exactly achieved and what is the software framework that allows me to get these capabilities, there's going to be like some different solutions in Web3 than it was on Web2. So I'd say, like, I mean, at some point we will get to the place where we will have quite enough infrastructure to build proper applications that competitive with Web2 applications. But in many areas we are not there yet. And as guys rightfully said, that we need to try to really work really tight with application developers to build those infrastructure and enable those exact use cases that help them today, so they can today onboard more users and drive more demand for the infrastructure. So it's like chicken and egg, but like we need to solve this puzzle.
So let's shift a little bit. Instead of looking at all our gaps, what are the things that we do uniquely well? Justina, what do you, when you see people coming and using ceramic at like scale, or saying, oh, I'm ditching my old thing because it doesn't offer what you offer, what do you lean into there? Or what apps have you seen that really set a new bar?
I think, okay, sorry. Yeah, so in general, I think the best thing about building on Web3 is the scale and building in the open. Like, that's the main reason as well why I'm such a big fan of open source, because not only you share what you are working on, but you get ideas from so many different developers, teams that are working on the same problems, and you kind of, you have that like togetherness in terms of working and building on top of things and sharing that. So I definitely see that, and I'm such a big fan of that. And also communities that surround every single project in Web3 is amazing. I love that part. Now, specifically about, let's say, ceramic and things, one of the key two use cases that we see right now is Web3 social. That is definitely one of the top use cases that we see. And here are the, I would say, two key reasons why we have teams like, for example, Orbis. If anyone in the audience heard of them, they're a really great project, and they basically allow users to own their data first of all, and that's the biggest advantage and difference from what we have in Web 2, because social media is so powerful, it's amazing. And now with things like a single sign-on, you open up even more opportunities for big companies like Google, for example, or Facebook, collect your data in so many different areas. So by building on Web 3, you allow users to make sure that their data is not stored on these like fragmented, centralized places. And then at the same time, the same composability and building in the open with other developers, the same data models, they are being improved by other developers, so they can make improvements faster and develop much faster. And then another one, I mentioned that in my talk as well, DAO tools as well. They are looking into how verifiable credentials could be stored in a more secure way on Web3, and how they can build necessary tooling for DAO. So this is something that we still see growing, but it's definitely a lot of interest from that end. So yeah.
Cool. Vuk, kind of taking it from the other side, those are great. You've obviously built some enormous partnerships and worked with people behind the scenes, a little bit like what Yevgeny said, like how do we bring partners to market in the same way that Justine is bringing users to market? What do you see as the pull through there? Why are partners signing up for Web3? What's pulling them in?
Yeah, I think it's generally because for the first time we are able to coordinate big like plots of people, and we finally have the ability to have particular actors focus on only one particular activity and have everyone focused on their parts, and together as a society we can coordinate in solving like larger problems. This is really not possible today, because like if you want to do anything in terms of like computing, you always need to create some cloud account. You need to have a company. The company needs to be like invoiced by that particular organization selling you that service and so on. But you don't have ways of like maybe pulling together resources in order to have a solution for a particular cause. For example, you could imagine having compute providers focus on solving like a particular disease because that's something important for a particular community, and then you could have like other communities basically staking funds or investing in that particular pool, and having an incentive for particular compute providers to like execute compute jobs that actually help discovering cures for that particular disease. That was never possible before, and I think that's just the beginning of like a much wider like coordination coordination infrastructure that we need as a society, especially in such turbulent times.
Yeah. Yondin, when you to extend what Vuk was just mentioning about collaboration, and Justina as well, actually, how do you see like organization happening, particularly around common problems that we need to solve? In a lot of ways, you're like working on a very common problem, transcoding, and decoding and things like that. What components should we be collaborating with, and what components should we be differentiating with? Where is the line in Web3, and especially in the area of coordination, where it's very hard to do? What do you think the right path is for us?
So for collaboration, I think just using our domain as an example, we spend a lot of time thinking obviously about video, but generally about how media content is handled and all the different computing infrastructure that's required in that. And I think that gives us a fairly unique insight into like some very domain-specific problems there. But if you zoom out and you forget about the fact that we're dealing with video and media, it can be very easy to just say that, oh, this is a distributed computing project. And because it's distributed computing, we can take a general framework and have that apply to any form of compute that you try to do. And I think that's the holy grail, right? Like, of course, we would all love to see that happen, but I think that is also theoretical and a little bit removed from the reality and practical reality that we have today. And while that might be a worthwhile thing to work towards, I think that is a gap and like chasm that I think is worthwhile bridging on the collaboration front, where it's like taking, like using us as an example, the time that we've spent kind of looking deep in this domain about like what is specifically quirky and weird about some of the work that we're doing here that makes it a little bit different from other types of distributed computing projects. I think having that insight being brought to the table and making that clear and having these conversations with people can be useful, because then it helps other people understand some of the intricacies and idiosyncratic elements of like these different domains. So I think that's an area where greater collaboration can help with. And then on the differentiate front, I'll keep it short. I think differentiation should be around, like once again, going back to that specific domain, like it's great to collaborate on these like shared technical problems, but at the end of the day, I think each of us also need to remain laser focused on like our users and that specific needs that they have. So to the extent that we should be collaborating, I think we should always be thinking about, will the fruits of this collaboration better equip us to serve the users that we think are underserved right now? And then that is the area for us to differentiate in. I think that's how I think about it.
Makes sense. Evgeny, I'll ask one more question, then I'll open up to the audience. You just raised a round. Congratulations. When you think about what investors are looking for in the space, you've heard a bunch of different ideas here, differentiation, extension, things like that. When you went through your process, what were they most looking for you to talk about? What did they want to hear that other people can lean into?
Well, I mean, investors in crypto space, they believe a lot in crypto in general, in tokenized markets, right? So a lot of investors look at different areas and see, if there is a way to create the token-based economy that, like let's say, for example, a lot of these examples are marketplaces like Livepeer or like Fluence. Like basically, we all do some sort of marketplaces. We have providers and we have customers, and then we connect them and we create the value. And the token basically allows to subsidize this the bootstrapping of this market, or like put additional rewards to providers or put additional rewards to the customers, and basically the enable higher efficiency than, it's obvious things, but instead of Uber, we have decentralized Uber. Because we eliminate the company, we can have lower margins, and we can power the whole economy with the token. So investors look at such areas where this model just makes sense. And if it makes sense in your area, then it's a good opportunity to really like replace the big tech with their current monopolies via thin, or like, well, you can call it thin or fat protocols, depends on the definition, but like the let's say fat protocols with thin margins that because of efficiency gonna distribute the value directly to whoever contributes to this protocol.
Great. I've been doing all the talking up here. Anyone in the audience have a question? Yeah, go ahead.
So we'll take you back in time to 2007. And what came in, what allowed actually the whole evolution of Web2 is the thing you're holding in the hand. Yes. What, in your opinion, should came along on the market to allow the evolution of Web3?
So I'll repeat the question, and then I'll toss it open to anyone who wants to answer. This transformed Web 1 to Web 2, arguably. What is the device? What is the thing that will unlock the evolution of Web 3? Did I capture your question right? Yeah. Okay. Who wants to answer?
Yeah, I would say like probably, I mean, how you should think about Web3, like the first use cases are going to be like the super slow, super cheap computing workloads. And if you think about, because that's where you can actually provide 20, 30x improvement over decentralized providers. So if you think what are those workloads, most likely that's going to be machine learning, maybe it's going to be inference. That's a use case where you can imagine a bunch of traction. Probably it's going to be a bunch of things around data processing and so on. Those are not as sexy as having an iPhone actually through an application calling a backend, but those are very different problems. And those are the kind of problems that we have today. Maybe what you're going to also see is probably protein folding and things like that that were basically impossible to incentivize. Maybe those now are becoming possible to incentivize, and you can see governments actually investing funds into really trying to solve those problems. But anything that is high compute needs to be super cheap, and when you get to a tremendous scale, you can see tremendous results.
Anyone else like to take a shot as well? Okay. I don't know, super bright out here. Anyone else have a question? Anyone? Okay. So, actually, Vuk, I want to open it up to whoever would like to answer this, but really extending that. Where's the pivot point? Where is it to, like, when you think about going beyond either what is possible in Web 2 or not convenient in Web 2, from a scale perspective, what do you think that is?
Yeah, I think we are generally in a stupid situation where we have like a coordination problem. Like all the tools are there, but we have no coordination between the different projects. So for example, Fluence has a great tech stack, but very few nodes are right now running Fluence because they focus on building the tech rather than focusing just on pure token economics. Then you have like Filecoin that has a great tech stack for high-val. IPFS is still not incentivized, so like it's super hard to actually have like that layer that is required for Fluence jobs to actually be able to run Fluence workloads. And then you also need to have like the separate layer of dev tools that are basically using Fluence technology combined with IPFS, combined with Filecoin, combined with a compute layer that is actually going to run the entire thing. Yeah, we have so many layers of complexity to just get to an executed job. Generally, what my opinion is, and this is of course the reason why we started working on the resource layer, is that we need to have a global incentive that basically allows infrastructure providers to run all of those networks on the same machines, and in that way being able to have like multiple workloads interacting between each other. Because we might not be able to incentivize someone running IPFS at this point, but we might incentivize that someone running IPFS if that is required to get a reward. That is also like incentivizing the compute networks.
Jan, you actually have an interesting problem, because, or not an interesting problem, just a different angle at it, right? It's not going to be a massive workload for you because ultimately you're serving users and they're viewing the video at the end of the day. What's the pivot point for you? How does it get to scale such that yours becomes the default or the better solution? More nodes, more people, more videos, anything in particular?
So I think the way that I think about it right now is that in the medium and long term, I do think that cost and the magnitude cost differential that Vuk mentioned is going to be a huge differentiator. However, until we get to that point, I think in the shorter term, where I actually see the pivot and where I actually see the biggest differentiation is what I talked about before, having this infrastructure by virtue of it being permissionless and people being able to build on it without anyone's kind of guidance or permission, leveraging that property in order to build things that might feel a little bit even unhinged or a little bit strange at first, but those being the applications that really demonstrate new media formats that aren't possible today. So think about how TikTok introduced a new media format. I think there's an opportunity in crypto and Web3 to leverage some of the unique value propositions of crypto around attribution, dynamic and automated value distribution to create new media formats centered around things such as community co-creation. I think one of the most interesting things that infrastructure can enable by being permissionless and open is allowing communities to build on top of that, co-create media and content or new types of things, and then having that value attribution and distribution reward them. I think those types of formats are the things that if we as infrastructure builders at Livepeer can enable in the short term will be the big differentiation. And then once we layer on the cost differentiation as well, we'll demonstrate the true value of Web3 infrastructure for video relative to the status quo.
Yeah. Evgeny, when you think about it's interesting because you have an interesting angle here. You're providing a complete platform, but you're below the things that end users and even maybe a lot of businesses are going to see. When you think about services that infrastructure providers can pull together that empower the people building on them to be truly advanced and implement some of the things that Yandin said, like truly creative things, what do you think some of those are?
Does it work? Oh, it works. I mean, this is just something, it's super hard to answer, because we have the whole community here that explore in different kinds of, use cases and experiences, like thinking of the new types of business models, new types of content, new types of, applications combined with different types of data. And we constantly, as a growing Web3 community, we are experimenting by applying the things to each other and see whatever works. And sometimes it's just random things work you cannot even imagine. So I guess in terms of combining different infrastructure pieces together, it's also not super clear how the future gonna look like. And I think what's important here is we just have to keep experimenting. We just have to keep trying to combine pieces together, try to collaborating, and see whatever really gets traction, whatever works for the user, whoever user is, whether it is a developer, whether it is a small or medium business, enterprise, consumer, mobile users, web users. Like, it's just so many layers here and huge space of experimentation. Just like quick example of Ethereum had this vision of, that financial application is going to be built and the token is going to be built. But there are also, like, if you remember, like 2015 or 2016 and 17, there was a lot of conversations about use cases of Ethereum much outside of fintech, like, all these smart locks, like I can send transaction to open the door, like, which is still makes sense. All these ideas are great, but we saw traction in the DeFi DAOs and NFTs, which were super unclear at the moment. So I think in terms of like Web3 and infrastructure, we can expect something like that.
Fair enough.
That somewhere where we not expect like something can happen.
Justine, I'll give you the last question. What, to extend Yevgeny's point, what experiments, what new things have you seen that give you the most hope for the future, and the things that get you really excited about, what's coming next?
I think probably the key thing that right now makes me really excited is overall decentralized science and machine learning space, which for me, when I started working in Web3 about 7 months ago, actually not that long ago, was one of my biggest questions and doubts, like, I'm leaving Web 2 and I did all this data ML kind of work, and like what's happening in Web 3, and I thought there is not much happening, but actually there is a lot. It's a really growing space, and the people are asking really, really great questions from how funding can be done better for research and how Web 3 can enable that, so that research is not locked and not like managed by some specific companies that can fund specific projects. To how can we do machine learning and all of this computation better in a more scalable and faster way as well. So like all of these projects that I see around Web3 data that are popping up, and that's one of the reasons why I'm part of Ceramic team, is because they are part of that ecosystem as well. I really hope that they will open up more opportunities for data to be more open, more shared, and also the same about all of these amazing projects that are working on these really hard computational problems, and yeah, really open up the network for some really great and interesting things. So I'm super excited about that. And throughout this week, last week here in Lisbon, I had so many interesting conversations with projects that are focused specifically on AI and machine learning in Web3. So yeah, this field is really growing, and I'm super excited about that.
Terrific. Well, thank you all so much for coming up and giving your thoughts.
Thank you one more time for David and all our speakers. We still have some time, like 30-40 minutes for networking. And we have some food, some drinks. So guys, enjoy. Thank you very much.